What we've got in here is liquid nitrogen. Nitrogen from the air, normally gaseous at this temperature and pressure. But here it's been condensed, and for it to remain condensed, it has to be very, very cold. So the liquid inside here is an astonishing minus 196 degrees Celsius or cooler. So, that cold, no one in their right mind would pour this on their hand. So what's happening here is the Leidenfrost effect, named after Johann Leidenfrost, who wrote the paper in 1756, describing how, when liquids boil, a gaseous barrier between the liquid and the surface that they're boiling on can act as a thermal barrier, protecting, if you like, my hand from the extreme cold of the liquid. So the key thing is that there's a big temperature difference between the liquid and the surface that it's on. Here we've got a very, very cold liquid on a room temperature surface. We can also do the same sort of demonstration with a room temperature liquid on a very, very hot surface, like a hot plate. So the surface right now is measuring about 37 degrees, 38 degrees. If we squeeze some water onto it, well, nothing much happens because it hasn't reached its boiling point. So now we are at 100 degrees Celsius, and clearly the water is boiling on the surface. Now it's reading 200. I'm going to pour the liquid on, the water on. And yes, we can see droplets of water elevated. It's getting a bit steamy in here. So we now have the Leidenfrost effect, and what's happening is that the second that the water touches the hot plate, it boils instantly, and the gas coming out at the bottom elevates the droplet and is acting as a thermal barrier, preventing any further transfer of heat from the plate onto the liquid. So it just seems to hover there and go on indefinitely. Or it would if it just didn't roll off like that. Similarly, the surface of this desk is so much hotter than this nitrogen. Exactly the same thing happens here. Who cares? Designers of boilers and kettles. 1800s, of course, steam was king. And even today, the Leidenfrost effect can be a bit of a curse when you're designing these kettles, which contain a heating element. And if you heat the water and the steam gathers around the element, that will act as a thermal insulator. And if you're just heating the steam around the element, that's inefficient. You might think when people are doing demonstrations with liquid nitrogen, they would be wearing these sort of gloves all the time to protect themselves. But actually, the Leidenfrost effect protects you pretty well, as long as you're not holding something for a long period of time that's very cold. And you can imagine the situation where the nitrogen gets stuck down here, held against your skin, and that would lead to the severe frostbite situation. So, goodbye gloves, hello Leidenfrost.